So I'm going to talk to you about something slightly more different, I'd say, but with a lot of stuff that is related to blockchain, right, if that's your interest. So I work for a technology company based out from San Francisco in California, and we basically specialize in in-memory computing and high-performance computing at scale, right? Yep. Is it the... It's a bit slow. Okay. So what is Gridgain? And I'll talk to you. There's a couple of concepts. There's Gridgain and there's Apache Ignite, and we'll get into that. So Gridgain is an in-memory computing platform, right, where it's durable, strongly consistent, distributed, right, and allows you to have many different ways by which you can process and change and work with data, right? So what does that really relate to, right? So where did we come from? And we'll talk about what Gridgain is and what these aspects are. So initially, we started back in 2007, right, as a proprietary distributed storage platform, right, for storing data. And soon we added compute capabilities, so the ability to distribute computations and process this data in real time. Now, we saw how the world is changing, how everything is kind of moving towards the open source direction, and we took a decision early in 2014 to take our software, right, as it was mature with many customers at the time, and open source it. And not only open source it and keep ownership of this product, right, and this project, but actually open source it and donate it to the community. And we created what is called today Apache Ignite, right? So Apache Ignite is the open source version of what our platform was, right? So what is interesting Apache Ignite is, if you're familiar with Spark and any other Apache products, is actually the second fastest project to graduate at top level, right? So you usually submit your project, right, to the Apache Software Foundation, and then it goes through a bunch of different tests and a maturity process before it's deemed as a top level project that people can use. So we did that very, very fast, only second fastest to Spark, which is very impressive. Now, we've only been running this project for about 3 years now in the open source world, and the contributors are literally growing day by day. The downloads are increasing, and I'm just generally having conversations with a lot of customers or prospects that I didn't even know are using this technology. So open source is definitely a fantastic avenue and a great direction for us to work in a transparent way, and of course allow us to innovate and share this capability with our customers and prospects and the world. So important points: very mature project, open source, free to use. If you need something that is production grade and to run Apache Ignite in production, then this is where you can talk to us, Gridgain, right? So right now we kind of maintain the enterprise edition, let's say, and the robust version of Apache Ignite. So if you wanted that consulting, the services, the enterprise edition to run in production, then the expertise is with the Gridgain right now. But there's nothing stopping you using the open source project. So what is it, right? So we mentioned a couple of words. It's really a distributed storage, right? So it's about storing your data and having the ability to scale out the storage of your data, right? So really you can imagine this as a collection or a set of computers or nodes, right? Which together they provide this data framework. It means it is strongly consistent. It means we can always guarantee from wherever you're going to read this data that you will get consistent reads, right? This is very important when you're dealing with transactions, right? And applications, especially in financial services, which actually, to this date, Fintech and financial services are one of our main customers and our main prospects that we deal with, right? We have applications that cover risk calculation engines, right? So the ability to do massive execution or parallel execution of a lot of calculations as close to the data as possible. So, or we do a lot of portfolio evaluations, right? Reevaluating your position of certain trades, right? For certain customers. Now, this requires the ability to look at terabytes of data or even petabytes of data, right? And calculate and run algorithms on top of that. And that's exactly what we can provide as a technology, right? So again, back to what I mentioned. It's all about that memory-centric distributed storage. And why do I say memory-centric is because we work in both worlds, right? We traditionally worked with memory only, which basically allows you to do things much, much faster, right? Since you're working with RAM. But more recently, we've actually expanded to also use disk, especially if you're talking about big data, right? And working with big data sets, RAM can be cost prohibitive, right? So one of the recent developments or recent additions we've added is the ability to work with disk, right? So once we have our data in the grid and we can scale, we can have consistent reads and really trust what we're reading from the data. We have persistency so we can recover from it. Now you just need many different ways by which you can process and affect this data, right? Data sitting in a data store is not much use if I can't do much with it, right? So this is the second part, I think, of the technology that makes it very interesting. We have a range of flexible and powerful processing APIs, right? SQL, full SQL capabilities, right? You can connect to the cluster using JDBC, ODBC, or native SQL clients, right? And execute any statements, not only select, but use full schema changing statements, right? Alter tables, change tables, load data using your SQL, and just generally that would lend itself very well if you're talking about analytics use cases, right? When you want to ask interesting questions about your data, and especially paired up with the ability to scale out over multiple nodes, right, where you can have petabytes of data. You can imagine that now the types of questions you would be asking and the information you would extract from this data starts to become very interesting, right? Of course, the other side of it is the transaction capability, and this is very important. Maintaining consistency of this data is because it allows us to actually have an operational style database or application, right? Perhaps, a payments application or a money transfer application. And then we can also have a trading application running on it. But imagine if you want to do analytics on all these transactions that are occurring. This is where we can bring these two worlds together, right? With the ability to have analytical type of workloads and queries using SQL, but also having the approach of using transactions and key value to do your operational type of stuff, right? Now, the other very interesting aspect in terms of affecting and processing your data and working with your data is really distributed computations, right? Which means, can I process my data as close to the source as possible, right? If you look at the traditional model, what we typically do with a database is we move the data from the database to the client, to the processing node, we do our changes, we do the logic, and then we send it back to the server, right? Or we commit it back to the data store. Now, this can be very challenging, right, in the sense because you have a lot of data movement around the cluster. And data is very expensive, especially now as we see the explosion of data. So moving data around the different nodes to do certain type of processing is not really where we want to head if you want to really achieve that next level performance, right? So as part of this cluster, as I said, we have this distributed storage capabilities. You can imagine that every single node in this cluster can now execute also logic or code. So whatever you were going to run on the client side, it's simply you submit it to the server side, and this executes as close to the data as possible. And why I say that is because you can imagine when you partition this data will end up physically on different servers. You have the capability of processing this data close to the server if you know with what key or what data set you're working with. And of course, some new developments and some new additions that we've been adding is machine learning capabilities, right? And continuous learning frameworks. So once you move your data, we have a plethora and a number of different algorithms which you can train your model and then use our same APIs, compute, transactions, and SQL to take decisions or take actions based on what you're learning from your machine learning capabilities. And I think this gives me enough time to try and plug into the whole story of this expo, which has been blockchain. I tried to put a good slide together. So, we've been chatting about this, and I've been to a lot of meetups and a lot of conferences where it's blockchain, and a lot of people ask me, where do you guys come in? You're a distributed technology, you can do storage. It seems you have a lot of similarities in with this blockchain world. How can you get the two to work together? And in essence, the simplest way to think about it is off-chain storage, right? The first one. If you think about the blockchain, one fundamental issue that you see in a lot of discussions is where do you store the artifacts that you generate, right? It's one thing to have a contract between two parties or many parties about what they're contracting about, right? But then there's usually an artifact or something that gets generated or something that they're transacting for, right? They're going to, let's say, buy a certain digital asset. Great, you can execute the transaction and guarantee the integrity of that transaction on the blockchain. but you wouldn't really store the data on the blockchain, right? You wouldn't store the actual digital artifacts. So this is where you can find a very interesting working model in if you have a blockchain solution right now, which is clustered and running over multiple computers or multiple servers, you can run Ignite equally as well on each of these nodes, right? And provide this distributed storage. As you're adding, if you even embed it as part of your Gridgain part of your blockchain solution, as you're adding a new node as part of your, let's say, blockchain solution, and new node joins the blockchain cluster, right? You're also increasing your capacity for storage. And at the same time, these can also be scaled separately, if you will. If you think that there's enough capacity for the blockchain nodes and they don't need any more to do and execute those transactions, and you want to separate out your storage, that is perfectly fine. You can just have them in two separate layers. And again, if you want to take this to another level, you can even try thinking about implementing your blockchain solution on Apache Ignite, because again, there's compute capabilities, there's service capabilities. It just allows you to build an application that is distributed and has this distributed storage that you can use. And that brings me to the end, I think just right on time, and not sure if there's any time for questions or that's it, right? So you can always come to the Gridgain booth. We can chat more about this, but thank you very much.
You can have 5 minutes for questions. Yeah, so they'll put up the Slido.
So we got 5 minutes, okay. So.
Yeah, great, thanks.
Got tricked. How do you compare other distributed file systems like IPFS and computational resources like Golem? I think they're very similar. You know, I was looking at Golem. I think Golem is very interesting because they have the compute capabilities. And I think it compares very well. I'm not sure what the capabilities are for executing compute on Golem. I think what Golem provides is the ability to pay out based on the usage or the capacity that people provide to do that computation. There is nothing stopping you, for example, to deploy that and use, let's say, the Ignite's fabric or underlying infrastructure to do that processing, right? So you can, I mean, we work with Java, so you can imagine Java Compute or Java callables coming in, and Ignite will be able to execute those locally, right? Or distributed in whatever fashion. But how do you count, and we don't have the capability, let's say, of having a blockchain right now to pay out based on that usage. Now, of course, it's something you can implement and work on top. In terms of a distributed file system, actually, we do have the capability for a distributed file system. If you want to work natively with files, we have what we call as Ignite file system, which is in memory, which, again, it's going to be files stored on each of the machines, split out in different segments. There's nothing much different in that situation. How different is it from Apache provides from big data processing? Okay. Well, Apache, I'm not sure. Apache is a foundation, right? So I'm not sure which project specifically, but our solution is tailored for big data processing, right? Especially after adding the persistent capabilities, that's really where you kind of allow to scale at that petabyte scale and run your processing. Okay, a lot of questions coming in. How do you see yourself different from other products like IBM and ESC flash drives? Well, we're not in the hardware business. We're really about running on any medium. So right now, just to elaborate, we can work with memory, we can work with SSD, and we can work with disk, right? We are also looking at NVRAM, right? And a lot of new technologies that are coming out and see how we can get our stuff to work. What is I don't even want to think about that question right now. Actually, it's not doing too bad the last couple of days, but yeah. Do you recommend investing in it? You know, I'm not sure I can say that out publicly, but yeah. So low latency is an important factor in finance. Aren't distributed ledgers inherently slower? It's a good point, right? And I think what blockchain is, it's a really, really, really slow database that is immutable and guarantees consistency of transactions between different parties. We're really tailored for the super low latency use cases, right? And for the high throughput use cases. So if you're looking to build a distributed ledger using blockchain on Ignite, I mean, you're still going to be fundamentally restricted by the speed of blockchain, right? If you used Ignite as a solution to build, let's say, a ledger that you can provide access to other third parties, then you can reach those speeds of millisecond latency, right? Again, how it works with blockchain. So simply put, right? You have the blockchain, and you have your smart contracts. Let's think about Ethereum, right? You can execute those contracts, guarantee the integrity of those contracts if we're transacting through a party. But usually if there's a contract between us, we're talking about something third party, right? If we're trading a skin on a game, for example, or something like that, perhaps that's stored in some other server, right? So the idea is the artifacts or what you're working with, the actual files, let's say, that you're exchanging, the digital content, you don't store that on the blockchain. You can store that off-chain, right, in Ignite, and then have a reference to go obtain that from that location.
Thank you very much.
Thank you.
Thanks so much. That was great.